Okay, we have comparing functions. So let's review what we do when we compare functions. Okay, so let's get into this. So here's a function. Here we have a graph. We have what the function looks like. It's a linear function. And we'll just review the question. So here we have a table. Goes in weeks and wheels remaining. Okay, so the initial number of wheels remaining is 20 more than the initial number of packs bearing remaining. The number of wheels remaining is decreasing, as you can see on our line, at a faster rate than the number of packs bearing remaining. So as you can see, we have it decreasing rather quickly here. And then you can look at our chart and wheels remaining is decreasing pretty rapidly. All right, let's go to the next part. Key features, attributes of the graph of a function such as intercept, behavior, end behavior, intervals of change, extreme values, average rate of change, and domain and range. Comparing rate of change, intervals. Okay, so here's some examples of intervals. I will do a mini lesson on this one. It just says, it goes over the different types, the open interval, closed, half open, half closed, positive infinity to negative infinity. And then it just goes through like the different greater than, less than, different types of graphs on here, all that. Average rate of change is the ratio of the change in the dependent variable to the change in the dependent variable of a function over a specified interval. So then here we have another function in our equation. So we use this formula to represent the rate of change, how we find it. And here is our graph. What it does, goes up, gives us the equation here. Here's our table. Okay, so we have three functions here. We have the equation, we have the graph, and we have the table. So then what you do is we put them in sequence, and here's kind of how you solve them. But I'll have you figure out the rest of the question on your own. But here's an example of a half pipe. The graph passes through the points at 20, 50, 30, 40. Substitute these values into the rate of change formula. Okay. Then we have ramps. And look at this. We have all this fun stuff here, this equation. Evaluate the function when x equals 20 and when x equals 30. Find the corresponding y values. Okay. Then flip. Let's go to the flip. So here we have a table. Table shows that the points 20 and 51 and 30 and 42 are part of this relationship. Okay. And slide. The description states that the points at 20, 52.5 and 30, 41 are part of this relationship. Substitute these values into the rate of change formula. So just different examples of what we would do with functions. All right, I will have you do this question on your own. Comparing key features. So let me go back. We have the end behavior is how the function behaves at extreme values of x. So typically negative infinity, 2, and positive infinity. So the purple lines, that's the end behavior. Intercepts the point at which the graph crosses the x and y. Intercepts, meaning it touches the x-axis, it touches the y-axis. So those are called intercepts. As you can see, there's 4 on this graph. Our next one here, extrema, the relative maximum and minimum points along the domain of the function. Okay, so the maximum and minimum points here. And then we have increasing and decreasing intervals, so sets of x values along which the value of the function is increasing or decreasing. All right, so then what does that mean? We have positive and negative intervals. So sets of x values where the function is positive above the x-axis. So here, the negative below the x-axis, so this way. All right, again, these are different types of functions. We have polynomial, radical, rational, exponential, which means that dramatic increase or dramatic decrease, logarithmic, and piecewise. Here, we have three different functions here and their key features. So function D, the function decreases towards negative infinity as x approaches positive infinity. Function is negative over the interval 5, infinity. Key features of f, the function is positive over the intervals of 5, infinity. The function has a y-intercept at 4. Key features of g, the function it decreases towards negative infinity as x approaches positive infinity. The function has an x-intercept at 4. Okay, now we have a couple other functions here. Here's our equations, table, and graph. Here's their x-intercept and y-intercept. And their end behavior, usually resulting in negative infinity to positive infinity. All right. So watch the video on your own, and the questions will have you do that on your own as well. This just goes through functions and kind of what you would do when solving. Skip the question. Hopefully that gives you a little bit better understanding of a function and how to compare and how to figure out the different parts on a graph.